All right, now we're now looking at target 2.6, and our mastery learning objective says I can solve a right triangle, by using trigonometric equations, Pythagorean theorem, and the triangle angle sum theorem to solve for all missing sides and angles. So just a quick review over Pythagorean theorem and the triangle angle sum theorem. Who's the Pythagorean theorem? Remember, our Pythagorean theorem is a squared plus b squared equals c squared. One thing on the test that some people missed was labeling your sides. Remember, a and b have to be your legs, and c has to be your hypotenuse. Okay? So here we have 12 squared plus b squared equals 15 squared, right? This hypotenuse has to go here. That's 144. That's 225. And then since they're on opposite sides, we subtract. Then b squared equals 81. And we take the square root, and b equals 9. So we're going to use that today, so using that Pythagorean theorem. And then the triangle angle sum theorem. All right, remember, the triangle angle sum theorem says that all the angles in a triangle add up to 180. So that means this 65 plus 30 plus x is going to equal 180. So we have 95 plus x equals 180. Subtract 95. X equals 105. Nope, 85. I can't math today. So that x equals 85 degrees. Okay. So we talked about that last unit, and it's going to come back now with our right triangle trig. All right, what we're going to look at today, actually, is solving a right triangle. So a triangle has, if I'm solving a right triangle, I want to know every piece of it. So if we think a triangle has 3 sides and 3 angles. So I want to make sure I know all 3 sides and all 3 angles. So here, what parts do I know? I want to look at my sides first. I know that QP is 10. So I know that side. I know that this angle P is 90 degrees. And I know angle Q is 65 degrees. Okay, so I know one side and 2 angles. So what do I still need? Well, for sides, I still need side Q to N. Right, I just need this. I still need NP, which is this. And then I still need angle N. Okay, so really there's 3 questions that are part of this one question. I have 3 things I have to solve for. So I'm going to start by solving for QN. So I'm going to redraw the triangle. I have redrawn it for you already. QN is where my x is going to go. Now I'm solving this problem. This is a problem where I'm solving for a side. Now we're just doing exactly what we've done for the past few days. Right? Here's my angle. So I have my opposite, my adjacent, and my hypotenuse. Not going to worry about my opposite side. So this is adjacent over hypotenuse, so that's going to be a cosine problem. So cosine of 65 degrees equals 10 over x. The x is in the denominator, right? This is what we looked at a few days ago. We still have to cross multiply. Equals 10. And then again, with these ones, when we get to this step, right, we still have to divide. So 10 divided by cosine of 65 is 23.7. All right, looking at our next one, right? So that's here. So I'm going to put that in my picture. Great. Looking at our next problem, we're now having to solve for NP. So I'm going to put my x here. I still have an angle and sides that I'm solving for. So then here, and here's my angle. I have my opposite, my adjacent, and my hypotenuse. In this one, I don't care about my hypotenuse. I've already solved for it over here, so I don't care about it in this problem. So with opposite and adjacent, I'm going to use tangent. Equals opposite over adjacent. The tangent of theta equals x over 10. Put it over 1 and cross multiply, right? So I have 10 times tangent of theta equals x. Oh, not theta. Sorry about that, guys. You should plug in for your angle as well. It's 65 degrees. So x equals 10 times, and now we're using tangent of 65. Anyway, we have 21.4. Now we have to solve our last one, which is for this angle N. So to solve for this angle, right, I only have something with one side. I can't use trig ratios. Trig ratios, I need two sides to use. So what I'm going to use here is my triangle angle sum theorem. Look, I have the x, I have 90, and I have that 65. So if you know two of your angles and you're finding your third angle, you're just using that triangle angle sum theorem. So then we get 155. We subtract that, and we get x equals 25 degrees. And now I know every part of my right triangle. Wonderful. Let's look at the next page. Okay, example 2, solve for all missing sides and angles. Okay. So what parts do, again, what parts do we know? Well, I know AB, right, is 12. And that's a side, obviously. And I know side BC equals 9, which is another side. And I know my angle B is my right angle. What parts are you missing? Well, we still need the side length AC. And then I need angle A and angle C. So I'm going to start by redrawing my triangle. All right, this is going to be my first part. to solve for this AC side first. So x goes there. And now on this side, I have two of my sides, and I want to find my third side. I'm just going to use Pythagorean's theorem. So I have A, B. Remember, your hypotenuse has to be that C. Nine squared plus 12 squared equals C squared. So that's 81 plus 144. 81 plus 144 is 225. Take the square root and C equals 15. Alright, the second thing I'm going to solve for, angle A. Again, I'm going to redraw my triangle, put the pieces that were given to me in, and then x is going here. Now I have an angle and two sides, right? So I'm going to use my trig ratios. Here I have my opposite, my adjacent, and the hypotenuse. So the opposite side, right, the hypotenuse is not important. I'm using the opposite side and the adjacent side. So that's going to be tangent. So tangent of theta equals O over A. And in this case, the tangent of x equals 9 over 12. Okay. To get rid of tangent, we just do the inverse tangent. Right. Our tangents cancel out, and we're left with x equals whatever this is, right? So in our calculator, we do the inverse tangent of 9 divided by 12. Inverse tangent of 9 divided by 12. And we get 36.9 degrees. We'll just round up to 37 degrees. Why not? So then a lot of times your students are like, well, can't I just quickly find this? The one thing is I always say use the sides that were already given to you. Don't use what you found, because if you were incorrect in... What am I trying to do? Sorry. If you were incorrect, like let's say you did this part 2 incorrectly, and then you use that answer to do part 3, even if you did part 3 correctly, your answer would be incorrect, right? So always use the sides that were given to you for your problems. So again, for this part 3, I'm just going to redraw the triangle. And now I'm solving for angle C, which is down here. Same type of problem as this, right? So we have our opposite side, our adjacent side, and our hypotenuse. Again, the hypotenuse doesn't matter. So we're using tangent. So then the tangent of x equals 12 over 9. So these are almost exactly the same problem, but this has been flipped, right? So again, we're going to take the inverse tangent of the tangent of x, and we'll do the inverse tangent of 12 over 9. Tangents cancel. So we get x equals and then we get about 53 degrees. So if you do it correctly, these should add up, right? You can check that these do add up. But again, we kind of want to make sure we use the size we've been given to solve for everything. All right, we're going to look at one more example, and I actually don't like the example that's here because I want to kind of go over something else that you might see. So just cross that out. Sometimes it won't give you the triangle. It'll make you write your own triangle. And it will say something like, solve triangle ABC if angle B is 90 degrees, angle A is 37 degrees, and then we'll say something like little b is 17. I'm making up numbers. Okay. So the first thing I have to do here is draw this right triangle. Right? I know it's a right triangle because it tells me angle B is 90 degrees. Okay? So angle B is 90 degrees, and we're using A, B, C. It doesn't really matter where A and C go, but B has to be your right angle. Okay? And then it tells us angle A is 37 degrees. Right? And then this little b equals 17. How am I supposed to know where little b goes? Little b is always opposite big B. Okay, so the little letter is always opposite of the bigger letter. Okay. So this is the triangle that we are going to solve. Okay. So now we'll go through our 3 parts. Right? What's something I'm missing? Well, I'm missing AB. So I'm going to quickly draw that triangle. Right? I know 37 goes here. 7 goes here. I'm going to solve for this missing side. So again, I have an angle. I have my opposite side, my adjacent side, and my hypotenuse. So my opposite side is unimportant, so I'm going to be using cosine. That means cosine of 37 equals x over 7. Since I'm solving for a side, I'm going to cross multiply. So I have 7 times the cosine of 37 equals x. And I can quickly type that in my calculator. And I get 5.6. That was this side, right? All right, part 2. For part 2, I'm going to solve for my other missing side that we have right now, that B to C. So I know 37, my right angle, and 7, and I'm going to solve for x down here. So again, I have my opposite side, my adjacent side, and my hypotenuse. In this problem, the adjacent side is not important. So I'm going to be using O and H, so that will be sine so sine of 37 equals x over 7, and put a 1. Cross multiply. I have 7 times sine of 37 equals x. And then I just have to do times sine of 37, and I get 4.2. Alright, the last part I have to solve for then. Oop, let's put that number in. The only thing I have left to solve for is this angle. So the things I were given was this 37, this 7, and this, that's a right angle. And so x is going to go here. And I am just going to use my triangle angle sum theorem. So I have x plus 90 plus 37 equals 180. So x plus 127 equals 180. Subtract from both sides. And x equals 53. And that is it.